But you spent last year on your marker.
Oh, I'm sorry. We should just, you know what, we'll just let the wall fall down, it'll be okay. Let everybody back in, you'll be fine. Okay, Rahat has his license. Do what you will with that information. So today's lessons, ladies and gentlemen, we are going to be changing the shape of the graph. We're going to be stretching it. We'll be stretching it narrower, wider, and we're going to be flipping it either up or down, or left or right. We've never done the left or right before with quadratics. Today we're going to do that. It's not a big deal. So in reflections and stretches, anytime you multiply, it's going to change the shape.
And Gustavo, where's your first quiz?
Tomorrow. All right. So if we multiply something, it's going to change the shape. If we add or subtract something, it's going to move it around the graph. We're going to get to a point where we're doing all of these at once, so sometimes it's kind of hard to see. And the invariant point, do you guys remember that from last year? We did talk about it.
The thingy that doesn't move.
The thingy that doesn't move. It's the same point on the original graph and the transformed graph. Oh, see, I wrote in here. And a very important point, a point that doesn't change between the original graph and the transformed graph. And so we did those last year too. So if you have a better definition or you know what an invariant point is, again, I think this year you want to start building some note-taking skills, especially if you're going on to post-secondary. What makes sense to you for your notes? Like, these are things that I won't see. What is the most important thing that you're taking away from it? Because that's a really important skill. Okay, you ready? Here we go. So today, graphs are going to look different. Yesterday was like the baby steps into it. Today, graphs are going to look different, but it's quadratics all over again. They're just on different graphs. Okay, what's the 2 being multiplied by? So if we have this original graph, it doesn't really matter what it is. If we're saying 2 and it's multiplied by?
2 times y.
2 times y. So what are we doing to our y's? We're stretching them by a factor of 2, right? So the math that we're going to do here, let's do a mapping rule, because those are awesome. So that would be the mapping rule that we do. Like, that would be the actual math that we do. So you would have a vertical stretch by a factor of 2. All right. Yep, Rahat?
So is it basically like taking like a fat parabola and making it skinny?
It would be taking a regular parabola and making it skinny, right? Because the width on this one is just regular. And if we're multiplying the y's by 2, it's going to take that graph and like stretch it up like this.
Oh.
Okay? Okay, so this next one, what are we multiplying by?
X.
X's. What do we know anytime we're dealing with the x? We use the reciprocal of it, if you remember that from quadratics. So the mapping rule would be xy. And we're not multiplying by 2. What are we multiplying by? 1/2. So this one, you would have a horizontal stretch. Okay, now I need to stress to you guys that you need to use that language. Vertical stretch, horizontal stretch, like it needs by a factor of. You need to use that language because that's going to give you maximum marks. If you leave part of that out, like I said, grade 12 is about getting really good at the details. If you leave that stuff out, you might miss a mark, not because you don't know it, just because you didn't say it right. Yeah.
Why is it 1/2?
Because remember with x, we always multiply by the reciprocal. Like when we did, I need a, did we do this last year? No, I don't think we did. We didn't put b in here, did we? I feel like we did. No, we didn't.
Oh, we did flip it.
Did what?
What did we flip? I feel like we've used the reciprocal of something before.
Like the reciprocal.
Parabola.
Yeah. No. Okay. All right. No, not piecewise. That was its own special torture. Just wait. Okay, so anytime we're dealing with the x, we're not going to multiply it by the number. We're going to multiply it by the reciprocal. I feel like we did this in grade 11 somewhere. I just can't lay my brain on it right now. Okay, so this is homework from last night or similar to it. Here's the original graph. It's just put on this graph just so we can see the original and the transformed on the same thing. So this is telling me the y's are going to be multiplied by 3. Am I doing anything to the x's? No? Hopefully not. So just like with last night's homework, you need to know what the original coordinate pairs are. So this one is 2 and 0. This one is 1 and 1, 0, 0, -1 and -1, and this one is -2 and 0. All right, you guys would agree with me? Those are the points? So that's the original graph, that's the f of x. Now, we could create a table of values with those points and do the math in it, but we don't have to. It's whatever works best for your brain. So now what we're going to do is we're going to take these coordinate pairs, and what are we going to do? We're going to multiply the y's by 3. So I'm going to work from left to right. I'm going to go through the coordinate pairs. If you'd like me to do it as a table of values, let me know. I can do that too. So what is this point going to be? Am I going to do anything to the x's? No. What's 0 times 3?
0.
What is that? It didn't move, so it's a thingy that doesn't move, right? It's an invariant point. So here, my point is at -1, -1. The x doesn't change. What happens to the y?
-3.
-3. So we are at -1, 1, 2, 3, right there. Now we're moving on to 0, 0. Does it change?
No.
Nope. What happens to this one?
3, 1.
1 and 3.
Positive.
And then 2 and 0, what happens to that one?
Invariant point.
It's an invariant point. And so I'm going to get my handy dandy ruler because these are all straight lines. So those 3 points that I just highlighted, sorry, would be considered invariant points on this graph. Does that make sense? On your provincial exam, what you'll see is they will give the original graph on the one you're supposed to do, but they do it usually in a dashed line. I just copied and pasted the graph over, I'm sorry. But you'll see this similarly, this sort of thing where you're graphing on top of the original, just so you can see it. Yeah.
So invariant points at this point that didn't move.
Didn't move. They're shared by both the original graph and the transformed graph. Okay, not hard. Did we need to do a table of values for that one, or are you okay just doing it with the points on the graph?
Just the points was easy.
Okay, cool. All right, here we go. You guys don't like seeing it this way? You get angry about that?
What's that? Don't draw.
Like this. So what does this really mean mathematically? This just means 1/3. Okay? So now, mathematically, well, for transformations, what does this mean? 3 times. So we're going to take, this tells us that we're going to take the x's and we're going to multiply them by the reciprocal. The only time you wouldn't multiply by the reciprocal is when there's a mapping rule. The mapping rule tells you the actual math that you're doing. So a mapping rule for this one would be xy maps to 3xy. So the mapping rule is the only time, like if you get a mapping rule, you actually do the math on the mapping rule. There's no x doesn't tell us a straight story. Mapping rules, that's why I like them, is they give us the math. All right. So we have -2 and 0. We have -1, -1. We have 0, 0. We have 1 and 1. And we have 2 and 0. Okay, those are my original points, just like on the last graph. Okay. Where's this point going? Over there. -6 and 0.
Wait, what?
What am I doing this time? I'm multiplying the x's by 3. So the -2 becomes -6. And I don't touch the y's, right? They stay. This one moves where?
-1 and 3.
How about -3 and -1? Oops. Sorry, I dropped my pen on the ground. 0, 0. What's happening with that one?
Invariant point.
Invariant point stays where it is. 1, 1 moves to
3, 1.
3, 1. And 2, 0 moves to
6, 0.
6, 0. And so on this graph, we only have one invariant point. We good? Let me highlight the invariant point for you. 0, 0. It's the only one that's shared. So here's the thing with invariant points. They can be confusing in just this regard. Sometimes it's a point that doesn't change. you might have that point repeated, but it's because another point changed to it. That's not an invariant point. It's the point that is exactly the same and untouched by the transformations. Okay, reflections. We did a ton of these last year. When we take the y and we flip it. We totally did do horizontal stretches. We did them because it was, no, it was, did we just do the a variable? There was a b in there. Where was the b?
We just hanged out.
No, that's the h and the k. Okay, I'm losing my mind. Okay, all right, but we did these a ton. What happens when the y's are multiplied by -1? Well, or if they were all negative, what do they become? Positive. So this results in a reflection in the x-axis. Remember, this was confusing last year because the y is times by -1, but it's a reflection in the x-axis. So really, if I have points here at 2 and 0, sorry, that's a -2 and 0, and then I have -5 and 1, 2, 3, 4, 5, -5 and +5, what happens? I take all my y's and I times them by -1. So this one becomes 1, 2, 3, 4, 5. So that becomes -5 and -5. What happens to this one? Anything? It's an invariant point. So it's like you took a mirror and put it along the x-axis, and your original graph is just reflected in the x-axis. Okay. So now we're going to do it to the other side. And now this becomes a reflection in the y-axis. Okay, what are we multiplying our x's by?
-1.
-1. What's the reciprocal of -1?
+1.
Still -1, right? -1, if you flip it, it's still -1. Okay. Why? Did you ask why?
Yeah.
Okay. It's a fair question. Okay, so -1. And what's the denominator on that? Nope.
1.
+1, right? If I flip that, if I do the reciprocal of it, it's going to be a +1 over -1, which when divided is the exact same number. So that's why reflections are just, they're straight, they're easy. All right, so we had the point -2 and 0, and we had this point -5 and +5. So now we're going to take all of our x's. We're going to take all of our x's and we're going to times them by -1. So we're going to be at 2, 0 and +5 and 5. And so what you should notice is it's a reflection in the y. So if I put that mirror right on the y-axis, they should be the same distance away from the y-axis. It should look just like a reflection. And I know we didn't do reflections in the x-axis last year, but we're doing it this year. Okay, so everything is easy peasy so far.
Oh, no.
Okay, now this is the difficult one because it gets a little bit confusing. Are you ready? Okay. And it might be easier for you to do this part first than write the equations, but we're going to do it. All right. So if we're reflecting over the x-axis, what are we multiplying by -1? If we're reflecting over the x-axis, what are we multiplying by -1? The y's, right? Okay. So we would write this as f of x, negative f of x, equals 3x minus 4. Now, proper grammar in math, would I leave that negative with the f of x?
No.
That would just be bad. So how do I get rid of the negative in front of the f of x?
So we just flip it.
Because it has an A.
You flip
No,
it.
we're not gonna,
-1 bracket, 3x minus 4 bracket.
Or multiply the negative over to that side.
okay, somebody said, it might be easier if you look at it like it's a y. Does that help if we do it like that?
Yes. So
Yeah.
Okay.
3x plus 4?
So we're gonna divide out that negative, right? So we're going to divide by -1. Whatever I do to this side, I have to do to everything on this side. So we would have y equals -3x plus 4. Okay? So nothing different. If you want it reflected in the x-axis, you times the y by -1. Just grammatically leaving it like that, we would never do that. That would be bad or bad.
Cheat sheet to remember this?
We've never had a cheat sheet, bud. Get your head straight. Sorry, Rahat, no cheat sheets. The formula sheet, I should mention that the formula sheet I gave out to you guys is the one from the last provincial exam. So I imagine, like, the curriculum hasn't changed. That's what you're going to get on your final exam. So those are all the formulas they're going to give you. That's it. There's no cheat sheets, just that formula sheet. You guys will be fine. There's nothing you guys can't do. If you survived grade 11, you will be wonderful in grade 12.
Oh, yeah.
Okay, y-axis, what are we multiplying by -1 this time?
The x's?
The x's. So we're going to have y equals 3 times a -1 times x minus 4. Because we're timesing, if we want it to reflect in the y-axis, we have to times our x by -1. So if I do all that math, that's going to be -3x minus 4. Okay, let's graph them. Okay, I'm going to grab this guy in blue. I'm going to graph the original in blue. You guys all know how to graph a straight line?
No.
Yes. Yes. Y-intercept. Slope. Please.
Yeah.
Thanks. It's like cry in the corner here. Okay, no, just graph. So that's my original graph. That's my original one.
She did 3 over 1. Go by 3 and over 1.
Start at -4, first point's at 0, -4, up 3 to the right 1, up 3 to the right 1. Okay, so now I'm going to do this one in green. So now this is going to be y-intercept at +4, and I'm gonna go down 3 to the right 1, down 1, 2, 3 to the right 1.
On like a test or anything, do we have to like change the colors?
Nope. But you will need to label them.
So what am I labeled as?
So I labeled that one negative f of x. Because really, that's what I did, right? I just multiplied the y's by -1.
I can put the equation.
You can totally put the equation beside it too, Steve. All of those would be very acceptable.
I have a feeling we're gonna need to use color pens.
I'm just gonna highlight this one because this is my original.
Black, blue, and green.
Perfect. Okay, is this a reflection in the x-axis? So I'm gonna put my mirror over it like this. So does this point on the original reflect down here?
Yes.
Yes. Does this point on the this point down here on the original, does it reflect up on the y-axis?
Yeah.
Yes. Is that a reflection in the x-axis?
Yeah.
Yes. For some of us who aren't super visual, especially when they cross each other, it's sometimes hard to see. I find doing this and looking down at it, making sure each point reflects, helpful. But that's me. I'm not a super, I can't see it. So this one I'm going to graph next in pink.
I can't grab that one.
How come?
I don't have enough space.
Oh, no.
You're supposed to do it on top
We
of each
don't.
other, right?
But could we do it backwards? Could you, instead of going -3, 1, could you go +3, -1? It's the exact same fraction. Just this way I'm not moving my points off the graph.
Never mind.
I wish you guys...
Yeah, I wish he wouldn't move his desk over so I could see that board.
Oh, I thought we were gonna do that this year.
He did do that this year.
Are we gonna do it? Are we gonna...
Can we graph it?
We probably should.
We probably should.
Every day, we'll see how far he goes.
Look how far he's, look at this progress today. I was able to see the board at the start of class. I didn't go that far.
But Miss Callan, I literally can't see
I watched
anything.
it when we were done.
What do you mean you literally can't see anything?
You got glasses on, don't you?
You have glasses, you're in the front row. You could sit on the other side, Rahat. You
Go
could sit
beside Steve and I.
you can sit on the other side, sit in front of Kieran, and then you're right in front of the board. Would that be helpful?
Yes, the board.
So this one is a reflection in the y, and I labeled this graph f bracket -x because it's the x's that I times by -1. And if I put my mirror on the y-axis, is this a reflection in the y-axis between the highlighted graph and the pink graph?
The very view of the Gessler reflection.
What? What do you have?
So pretty straightforward. Pretty straightforward. Are we good to move on? Or are you guys still graphing?
Good to move on.
Okay. Okay. Let's talk about what happens. Generalizations. What happens if the A is outside the f of x? What happens when the A is outside? So if that's the case, if the A is on the outside of the f of x, we have a vertical stretch by a factor of A. If we did it as a mapping rule, And we're just using the letter A, it could be any number.
So A can,
Any number. Good call. Okay, if the number is inside the brackets with the X, we're gonna have a horizontal stretch.
Chill.
Miss County, horizontal?
Horizontal. Why don't you guys like that?
That's horizontal.
It's new. So it's a horizontal stretch by a factor of 1 over b. So we're doing that reciprocal.
What?
All right, what about this one? Reflection in the y-axis. If the math is happening, if the negative is on the x, it's a reflection in the opposite axis. So this is going to be a reflection in y-axis.
Wait, why is it the y-axis?
Because you're changing your x's, so they'll switch places. So your y-axis is like your mirror.
isn't it just like a negative to the y-axis?
No. If it's a negative on the x, it's the opposite axis. So if it's a negative on the y, where are you reflecting? X-axis.
So if you're negative on the x plus y.
Mm-hmm. And you might, like I say a reflection in the x-axis, some places you might see it will say about the x-axis. I think it's just a different view on it. Is that it, Steve? Did you flip? Is it just the assignment next? Nice. We're done. I think we're done this lesson. Pardon? We're done pre-cal? Yeah. We've done 2 lessons. We're good.